Hello friends, today we'll start current electricity. So let us give a brief introduction of what is current electricity. Now we know all charges, whether they are free charges or bound charges, these charges are considered to be at rest. Now charges in motion, this constitutes an electric current. This constitutes an electric current, charges in motion. Now charges flowing from clouds to earth during lightning, this is an example, but the charge flow that takes place, it's not steady. Now again, steady charge flows, where can you see the steady charge flows? Now in the cell of a torch or a clock. Now I think you have understood about this charges, and now we'll go to learn about electric current. So imagine a small area held normal to the direction of flow of the charges. This is a small area, this is a small area, and this is held perpendicular to it. Okay, this angle is 90 degree. This is only a side view. This is only a side view. Both the positive and negative charges may flow forward and backward. Both it can move both forward and backward across the area. Now in a given time interval t, let q plus, the charge flow is q plus, be the net amount, that is forward charge minus the backward charge. So similarly, net amount of negative charge that flows is q minus through the area in forward direction. So we will get net amount of negative charge flowing in the forward direction, q is equal to q plus minus q minus. This is proportional to t time for steady current. This q is proportional to time t for steady current. Now we know I is equal to, therefore I is equal to q by t. I means the current and q is the charge and t is the time, which is in the forward direction. If I is equal to, the minus is the minus q by t, then it is in negative direction. Now let delta q be the net charge flowing across the cross section of the conductor. If this is the cross section, if this is the conductor, and delta q be the charge, net charge flowing through it, delta q. And the time taken for this moving from this side to this side is the delta t, then it is given, means current that flows for the time t with respect to time, we can get by limit delta t tends to 0 del q by del t. Del t is, in the previously, t is the time, for passing through it, it is del t, so t plus del t, so the net delta t will get t minus t plus delta t. The SI unit of current is meter, it's capital A or ampere. This will be written in small letter and this is in capital letter. You must not write, this is wrong. If you write like this, the ampere, this is wrong. You can write in this way, this is right, and this is also right. Okay, so example, current in average lightning, the exchange, the power is that the thousands of amperes, 10 to thousands of amperes, and in nerves, very microamperes, in nerves in our body, the current is of the exchange of microampere. So next we will study electric currents in conductors. So stay tuned. Bye for the time.